I think this part you have already know how to do, so we can speed up. First, create a standard project here and then name your project. Select the device and also the programming language. Okay, and into this interface, we right-click device and click Add Device to add this EtherCAT master and EtherCAT master software soft motion. And then we need to before we add the servo driver, we need to import the servo uh, discrete file, device discrete file to your PLC to your software. If you are use Wecon, then you don't need to do this part this step because our software have already uh, built in this file. But if you are using policy software, then you need to import the XML file of your driver. And how to import? You can click this tool and this device repository, and here to add your device. Here, install your the file of your driver. And then you can right click this EtherCAT master soft motion and select the driver device you import. And the last you need to right click your driver and to add the motion axis to bind to this driver. And now we need to connect the PLC to PC. First, we need to set the same set the IP of PLC and the PC in same LAN, and click here communication settings scan network to connect your PLC. And here we also need to set the MAC address of your EtherCAT master. Double click this EtherCAT master soft motion, and in general you will see this source address. You can select it by this. Select network by name and click select and select the one select the name ETH1. Motion axis configuration. After add the motion axis, we need to configure it. Here is the axis type. If you are connect a real motor, then you need to select this finish or modular. Select these two. It's like a linear and rotary mode. In our last class, I introduced the linear encoder and the rotary encoder, just like these two. And also some other limit setting, velocity setting, acceleration, deceleration setting. And also this, you can see the velocity RAM type. Default is T-type curve. If you want to make your movement more smoothly, you can select this other speed curve. And here also have software limit. For linear mode, we can set negative limit and positive limit for your driver. and click this activate to enable the software limit. And in this scaling and mapping, here we can here we can set the uh, we can configure the relationship between the motor and the user unit. How to understand? For example, with this setting, uh, it means when we set one unit in our function block, for example, we set the target position as 1, then our motor will rotate 360 degree. It means one road. And how to set uh, this value? It depends on your motor. Uh, for example, uh, your motor is 17 bit. It's about sorry. This is the resolution of 17 motor. And here we need to set it as we need to set it as to 20,000. Yes, 20,000 in HEX unit. So this is the setting for 17-bit motor. And now let's open the software to do it one step by step. Created the project. And now we have already connected our PLC. And here in device, right click, add device, field bus, and EtherCAT master soft motion. And here we double click and select network by name. Device environment. Wait a moment. Update device. Okay, and here we need to select this one, ETH1, this MAC address. And the next step, we need to right-click this EtherCAT master submotion and add device to select our driver, Wecon server driver. And here you can see in my software here have different version of the VT3E file. And here we need to select the version which is same with your driver. For example, your driver, the firmware of your driver is V1.12. Then you need to select this one. And if your driver is the firmware version of your driver is V1.13, then you need to select this one. And here, right-click this driver servo to add soft motion axis. And if you are connecting 17-bit motor, then you need to set this as this one. If you are connecting, for example, 23-bit, then you need to enter this value here. If you are connecting 23-bit motor. Okay. And here we can right-click to rename our axis name. So it will be convenient to write this axis name in our function block. So after these steps, then we can start to program to control our axis. And if you maybe some people have no VD3E driver in your site, so you can test it, or you can finish your homework by at least virtual axis. You can right-click this soft motion generate axis pool and select this axis. Okay, and now I will show you some simple function block to control the one EtherCAT axis. First one is MC power. We need to use this function block to enable our driver. For this output, because I don't need it, so we don't need to create it variable and and bind it to our output side. And here we use this one virtual axis S0 enable. For bool variable, you can directly enter true or false. So now we can use this function block to enable our driver. We can log in to check it. So we can see this virtual axis is in working status. Here we delete this one because I'm going to show you with this virtual axis. Okay, you can use Control and F7 to write the variable. So we can see for now this virtual axis is in enable status. And then we can add another two function block to read the position and the velocity of this virtual axis. Read actual position. And rate velocity. Here we need to change the location of the function block. Okay, S0. And then we delete this output terminal. Okay, and now we can insert another network and create some function block to move the axis. This function block can make our axis run in a setting speed. Move move velocity. Okay, and here you can double click the function block to check the detail information of this function block. You can see here have a very detailed description of this function block, the input terminal and the output terminal, and how they works. Okay, and then last uh, we can add another function block to stop our axis. MC stop. Let's compile and log in to check it. It's no target. Oh, sorry. Here an output should be blank. Okay, now no error. First, let's enable the uh, axis. And here, after the so enable, here we will have an output in status, and we use this stepper output to enable this read position. And we use the valid output of this read position to enable another read velocity. So now our position and speed is both zero. And we run this move velocity. So here you can see the speed is 10 and our position is increasing. And we run this MC stop. Now the axis is stopped now. And this function block is, you can see here, we have an output about this command about it. It means this function block have been in interrupt or have been stopped by this function block. Okay. So now let's continue to add some positioning function block. For example, move absolutes. Uh, Here we can use same variable. Okay. Set. Compile and log in again. First, enable the axis. And let's set the target position as 100 absolute position and run it. So the axis, the motor will go to 100 position absolute, 100 absolute position and stop. And this function block will output this down terminal. Set the position as 0. Stop the axis. Now position is in 241. Let's go to 0 position. And wait a moment. Oh, okay. So but now it will go to 300, and I want to say you can see this function block. If I change the speed to from 10 to 20, here the speed will have no change because this function block is a rising edge trigger function block. So it means we can't change the velocity or acceleration, deceleration in real time. This is different with LX60, 6V, because in LX6V we have another input terminal called continue update. If we enable that input, then we can real time to change our velocity. So in code 6, in Wecon 6, how can we change our speed in real time? We can use another function block. It calls this one, mcset override. Here we have a factor of our velocity, acceleration and deceleration. The setting range is between 0 to 1. Okay, let's log in. Now our speed is 10. And if I here set this as 0.5 and enable this function block, you can see the speed will be changed to 5. Now it's changed to 7. So if you have a requirement to, for example, to change the real-time speed, then you can use this function block to realize this. Okay, so this is the introduce about how to control the axis, EtherCAT axis. Uh, even through I I show you with this virtual axis, but it's same with the EtherCAT axis. Only there are no difference. The configuration is same device. This is the configuration of the virtual axis. Sorry, of the EtherCAT axis, and this is the configuration of the virtual axis. The general part is same. So for today's homework, you don't have to connect VD3. I mean, you can finish it only by PLC. And uh, yes, yes. And this is our today's training. Do you have any questions? If no questions, we can ask Molly for today's lucky draw. Yes, and you can, if you have any questions during protest or testing, you can send the question to group, and when we see it, we will answer it.